Alright guys, I'm going to go over the rest of this. Hopefully this doesn't mess up again. Um, so we're finishing 1.5 and Firestarter 11 for Firestarter 12. On number 1, we want to make sure that right away there will never be any decimals in this section, so no decimals. Decimals are, when it comes to radicals, decimals are an estimation. Decimals are rounding. Radicals are irrational. They go on forever. The decimal goes on forever and ever. So no decimals allowed. It's a big idea of this section. So the first half of this section is basically just learning how to use radicals again. You should have done a little bit about this before in other math classes, but you probably forgot. So if you give me decimals, 0 points. The biggest key for this is going to be understanding that we are looking for these red numbers as factors. Right? These red numbers, they are the perfect squares. Right? We want those numbers to be our factors. So we are going to look for the perfect squares as factors. They're going to change into the purple numbers. Alright? That's going to be our big idea. So look, I'm looking at 500. 500 right here is not on my list. I do not see 500 anywhere. I go through it all, it's not there. I want the biggest red number. I want the biggest red number, right? Or perfect square. If you pick a small one, like let's say you did 4 first, it goes into 500. It's going to make your life a lot more difficult, all right? So we don't want to do that. We want to make sure we always pick the biggest red number. So I look and I start at the bottom. I always start at the bottom. Remember our friend Drake, he wasn't really talking about starting from the bottom in life. He was actually talking about the starting from the bottom in math. So we start from the bottom. I find out that 100 goes into 500 5 times. So 5 times 100. So this is going to change into, and inside the radical, this is what the product property tells us. Now, 5, this guy right here, he is not perfect. So I think of the radical as a jail. So if you're in the radical, you're in jail. You're only allowed to leave jail if you're perfect. So 5, he's never going to be allowed to leave jail. He's not perfect. 100, he is perfect. Now remember, he has to change. Because if you're in jail for something and you don't change, when you get out of jail, you're going to go right back to jail. So 100 is going to change. So this is going to turn into our not perfect murderer dude named 5. And then 100, look, 100 changes into 10 squared. So he changed. He's perfect. If you are perfect, you get to leave jail. But you have to give up this little 2 because the square root and the little 2 cancel. So I'm left with this 10 turns into 10 outside the jail. So look, 10 squared, got to leave jail, he changed. So 100 changed into 10 outside of jail. 5, he's in jail forever. Done. That's it. That's all we're doing. So my recommendation for you is always to make one radical and deal with one radical at a time. So like number 2, the first thing I'm going to do is I'm going to realize that this guy, 3 is not in jail. He cannot mix with 12 and 6 who are in jail. So guys who are in jail can be put together with guys who are in jail, as long as it's multiplication, which it is. So this, I'm going to use the product property. I'm going to turn it into 12 times 6, which is 72. Now once again, I'm going to look for my list. I'm going to look for 72. 72 is not on my list. Look, I see 81, I see 64, I see 40. If 72 is on my list, it'd be perfect and the radical would go away completely. But it's not there. So I got to find a number on that list that goes into 72, 36. So I have 2 and I have 36. Now remember, I'm going to turn this 3. He's just out there outside waiting. 2, not perfect. He's going to stay in jail forever. Times 36, he's perfect. So 36 is going to change. Remember, 36 is going to change. So he's going to change into 6 squared. So now I have 3. 6 is now outside of jail, so it's multiplication, not addition, it's multiplication. And 2 is in jail forever. So last thing I do is 3 times 6 is 18. So my best answer is 18 square roots of 2. All right. Number 3, there's a couple different ways to do it. It's really up to you how you do it. Like what I would probably do first is notice that, hey, 25 is on my list. It's perfect. So before I do anything, I always try to get rid of, if I see a perfect square, I just deal with it right away. So look, since he's perfect, the jail just disappears. Because that is 25, which is 5 squared. The square root of 5 squared is just 5. So now I'm going to multiply all 3 things together up front. 1, 2, 3. So I'm going to end up with equal to negative 30 times 2 is negative 60 square roots of 12. I always try to do that if possible if I need to see a perfect square. Now I'm going to look and I'm going to say 12. Is 12 on my list? Is 12 on my list? I see 16. I see 9. I don't see 12. So then I got to find a number that goes into 12. Well, how about 3 goes into it 4 times, and 4 is on my list. So this is going to turn into negative 60 square root, but instead of 12, I'm going to rewrite it as 3 times. Remember, 4 is perfect. So now he is 2 squared. He had to change so he can leave jail. So remember, 3 is a murderer. He's not allowed to leave jail. He's got to stay there forever. 2 squared leaves jail as long as he comes out as just 2. So it's going to become negative 60 times the 2. And inside the jail is 3. So my best answer should be negative 120 square roots of 3, or negative 120 radical 3. All right, good, not good, good. All right, 4. 4 is a little bit different. So what I'm going to do for 4 is and what I tell everybody is fractions are hard. So instead of dealing with these fractions, square roots are hard, fractions are hard. So instead of dealing with the fraction and the radical at the same time, I'm going to take the radical to the top, and I'm going to take a radical to the bottom. All right, so I have radical 25 over radical 3. Hopefully remember that 25 is perfect, right? And the square root of 25 is just 5. So this is going to turn into 5 all over radical 3. Now if I look at the bottom, 3 is as simple as it can be. So 3 is simplified because there are no numbers that go into 3. No numbers that go into 3. But we have to remember a rule. One of the rules we have to remember is no radicals in the bottom. All right. We're going to spend a whole lot of time talking about conjugates later. So this is going to be called a conjugate. So I'm going to talk a lot more about this coming up. But I'm going to multiply by radical 3 over radical 3. So I'm going to multiply, notice I'm multiplying, by radical 3 all over radical 3. We're going to talk about this later, but this is called a simple conjugate. And the idea here is this guy right here, this box, this equals 1. So even though it doesn't really look like 1, it is definitely 1 because it's the same top and bottom. So I'm not changing this, I'm just making it look different. All right, now I'm going to spend a lot of time talking about that over the next couple of days. So we should end up with 5 radical 3 all over the square root of 9. because 3 times 3 is 9. Look, 9 is on my list. Well, the square root of 9 is 3. So my final answer for this, believe it or not, is 5 radical 3 all over 3. This is simplified. Even though it doesn't look as simplified as it began with, it is because, look, there's no radical in the bottom. There's no radical in the bottom. This is a conjugate because I had to multiply by something that made the radical disappear. We're going to talk a lot more about that later coming up, but for right now, that's all we need to know. We'll get into more detail with that. So number 5, I'm going to split the, first thing I'm going to do is I'm going to take the radical at the top and bottom because I see a fraction here. I hate fractions. I know you guys don't like them. So this is going to turn into 1/2 times radical 2 over radical 11. If radical 2 was like our only problem, there was no fractions involved, radical 2 would be done because it can't be simplified. Same thing with radical 11. The only reason we have to do anything with this problem is because there are no radicals allowed in the bottom. So this is where I'm going to use this idea of conjugates again. Well, like I said, we'll talk a lot more. But conjugates are just something you multiply by a radical to make the radical go away. So it's like a pair. So I don't care about radical 2. Radical 2 is not breaking any rules. I care about radical 11. So I want radical 11 to leave. To make radical 11 leave, I have to multiply by radical 11. That's the conjugate pair for radical 11. There's going to be a simple set of conjugates and a complicated and a more of a hard set of conjugates. This is simple. So basically, if it's just a radical, you multiply by that exact same radical, the radical will disappear. Now, to make sure I'm not breaking any rules, my box always has to equal 1. So I always start with the bottom, and then I make the top match. So the top and bottom are the same. That means it equals 1. If it equals 1, I'm not changing any rules, so we're good to go. So this is going to turn into 1/2 times radical 2 and radical 11 are radical 22 all over radical 121. 121 is on my list. Perfect. So 121 is going to turn into just 11. So I end up with 1/2 times radical 22 all over 11, and then finally I'm going to multiply the tops together and the bottoms together. I end up with radical 22 all over 22. Like I said, that's a little bit more complicated. We're going to spend a lot of time talking about conjugates. So as they're simple conjugates, it will get a little bit more complicated than that going further. Alright, just to finish this up, I'm going to do Firestarter 11 real quick, and then we'll finish the notes probably tomorrow. So Firestarter 11, look, first thing we want to do, this is just a way to get you to learn some of these perfect squares. 121, 6 squared is 36, 19 squared is 361, 10 squared is 100. I've made it out of order so you didn't have to see it to think about it a little bit. 289, 9, 49, 25, 64, 169, 324, 16, 289, 324, 1, 225, 144, 404. Hopefully I didn't make any mistakes. I was doing pretty quick. So evaluate, remember, no decimals. So what I'm going to do is I'm going to put 50 and 3 together. It turns into the square root of 150. I'm going to look on my list for a perfect number that goes into 150. All right. The biggest perfect number that I see that goes into 150 is 25. So this is going to be 6 times 25. Remember, 6 is not perfect, so it doesn't matter. I really care about 25. So remember, 25 is actually 5 squared. So if you want to do this without like showing every little step, this is kind of how I do it. I put the 6 guy, he's going to stay in jail forever. 5 squared is going to leave jail and turn into 5 square roots of 6. But I at least need to see this work right here if you want to get some credit. All right. Now me, 150 over 50, look, this, sometimes you break them down the radicals individually, but I notice right away that 150 and 150 go into one another. So I actually do this first, because 150 divided by 50 is just 3. So this turns into the square root of 3. And that's as simple as it can get. There are no perfect factors. No perfect factors other than 1. So this is done. That's it. And that's it for Firestarter 12. The keyword for this, for part 2, is square. The keyword for part 2 is square.